Hello and welcome. My name is Ian Fletcher. I am the Senior Product Manager for Temperature Resistant Coatings, and I shall be giving this presentation on maintenance solutions for CUI and cyclic temperatures, which will take around 30 minutes. In this presentation, we will cover the introduction to corrosion under insulation, CUI, its causes, implications, and challenges. I will then introduce AkzoNobel's product offer to combat CUI in maintenance situations and highlight its key features and benefits before closing with a summary. It is fair to say that maintenance in the oil and gas industry has changed dramatically over the last 10 years. Facility owners are more than ever looking to reduce shutdowns, improve plant efficiency, and extend plant lifetimes. With this comes the increased industry understanding about CUI and its impact, and the ongoing desire for pragmatic, high-performance and cost-effective coating solutions. So what actually is CUI? Corrosion under insulation occurs due to water ingress through an insulation system, creating a highly corrosive environment against the underlying steelwork. And CUI's corrosion rate can be up to 20 times faster than atmospheric corrosion, resulting in steel loss of between 0.5 millimeter and 3 millimeters per year. And as shown before, corrosion of the substrate is difficult to identify without the removal of the insulation and can therefore go unrecognized for significant periods of time. As a consequence, there is considerable degradation of steel piping and vessels with the potential for catastrophic failure. CUI largely results from damaged cladding as seen here. In this case, contractors have walked across insulated pipes, probably as a shortcut or because there was no other way to access an area of the plant, and as a result, the cladding has split. As you can see in this schematic of an insulated pipe, water easily enters damaged cladding. Over time, the water starts to accumulate towards the bottom of the pipe. The hot pipe heats the water and dissolved salts start to accumulate on the pipe surface. The aggressive environment accelerates the corrosion process, which if left unchecked will lead to catastrophic failure. CUI typically occurs between just above 0 degrees Celsius and 170 degrees Celsius, and is at its most severe at around 60 Celsius. It is fair to say that very little equipment experiences a constant temperature. It may undergo cyclic temperature processes and will be at ambient during a pre-startup and shipping to site, during annual shutdowns and maintenance, and during unplanned shutdowns and outages. So it is fair to say that all piping and equipment under insulation will enter the CUI temperature range at some point in its life. On a downstream oil and gas facility, the potential for CUI is vast. It is said that approximately 65% of the insulated area in a refinery or petrochemical plant is operating at below 230 degrees Celsius. A 140,000 barrels per day refinery will have approximately 150,000 square meters under insulation, of which 27% will be in the CUI zone. And an ethane cracker unit has 43% of its approximately 120,000 square meters insulated surface area subject to CUI conditions. With so much piping and equipment subject to CUI, it is no surprise that CUI maintenance work can take up more than 50% of a typical oil and gas facility's maintenance budget. Indeed, it can cost over €1,000 per square meter to scaffold, open up the insulation, prepare the surface, apply a protective coating, then make good the insulation. And then there are also the additional disruption and safety issues. With such a heavy impact on resources, when CUI maintenance has to be carried out, it needs to be done right first time. Maintenance on operating plant presents its own challenges. Blasting can be impractical or restricted in operating facilities, so hand tool surface preparation is widely used. High temperature coatings are particularly sensitive to low surface preparation. Site experience shows that coatings in CUI conditions applied onto hand-prepared surfaces can fail in less than 2 years. But with operational losses due to shutdown equipment costing more than $100,000 per hour, the ability to carry out planned or even emergency maintenance whilst the facility is operating can be very attractive. However, the need to coat operating piping and equipment causes technical and practical challenges for traditional coating technologies. Although most traditional solutions can be applied at elevated temperature, very few are actually formulated to be applied at such temperatures. And so this potentially reduces long-term performance and leads to extra uncertainty and cost. When it comes to hot application, many of the existing solutions do not meet functional requirements. Some coatings have poor workability, resulting in reduced application quality. In many cases, the coating needs to be brush or roller applied, and this presents difficulties for coatings formulated for ambient temperature application. Some coatings show early failure due to poor surface preparation. Most existing high temperature coatings, particularly for CUI service, usually require higher levels of surface preparation. As they are not designed for hot application, they dry too quickly to enable them to adequately wet the surface, reducing adhesion and performance. In the next few slides, I shall present AkzoNobel's product offer for CUI and cyclic temperature applications. For planned maintenance shutdowns and regular maintenance for process piping and equipment operating below 230 Celsius, Interbond 2340 UPC should be used. For planned maintenance shutdowns and regular maintenance for process piping and equipment where operating temperatures are cyclic and are between 230 Celsius and 400 Celsius, Intertherm 751 CSA should be used. And for applications to hot process piping and equipment operating between 60 and 230 degrees Celsius, Intertherm 2205 is the product of choice. This chart shows the operating temperature ranges for the three products. All three products can be used at cryogenic temperatures, as well as temperature ranges from ambient to high temperature conditions. But when it comes to direct-to-hand prepared hot steel applications, Intertherm 2205 is by far the best choice with hot steel applications from 60 to 205 degrees Celsius. This product was developed in close cooperation with a national oil company specifically for hot steel applications. The rest of this presentation will now focus on Intertherm 2205 in detail. Interbond 2340 UPC and Intertherm 751 CSA will be covered in another presentation. Introducing Intertherm 2205, a novel hot spread epoxy technology. Intertherm 2205 is a maintenance coating specifically designed for application to hot, hand-prepared steel. Intertherm 2205 is a user-friendly maintenance coating specifically designed for combating CUI that helps generate time and cost savings through easy application and improve performance over hand-prepared hot steel. It is a next-generation hot spread epoxy phenolic with hot application to 205 degrees Celsius, high temperature resistance to 230 degrees Celsius, can be brush or roller applied, has excellent tolerance to hand-prepared, i.e. ST2 substrates, is fast curing with coating and re-insulating in 15 minutes at 100 degrees Celsius, is 85% volume solids, its minimum surface application temperature is 60 degrees Celsius, and it can be used at cryogenic temperatures down to -196 degrees Celsius, but must be applied at 60 degrees C first. And its typical scheme is 2 times 100 microns. Let's now look at some of Intertherm 2205's product features in more detail. Firstly, what is the benefit of hot spread technology? Here, Intertherm 2205 is applied to a hot panel at 150 degrees C. The first thing to note is how well the coating adheres to the brush, so enabling excellent transfer efficiency from can to substrate. Second, you can see how workable the coating is on the hot panel. This is its hot spread characteristic. There is very little solvent released. The coating clearly maintains a wet edge, allowing it to be applied across the whole face of the panel in a smooth fashion, with a low level of brush marks remaining in the film. Contrast this with an example product of the inert multipolymeric matrix type. Straight away, you can see the amount of solvent emitted, that there is no wet edge, making the product very hard to work with. And you can see that the product dries to leave a very rough surface. And here is an example epoxy phenolic being applied to hot steel. Again, you can see a lot of solvent being emitted. The issue with highly solvented coatings being applied to hot steel is the risk of pinhole formation. Pinholes lead to early corrosion onset, and so clearly coatings that contain pinholes are a huge CUI risk. Conversely, a coating formulated for hot steel application with a low solvent content and a long wet edge does not produce pinholes and so delivers excellent performance in service. Here is a coating that is not of a hot spread technology type. After less than 2 years in service, it is performing very badly. To testing for surface tolerance. Intertherm 2205 is ideal for use on steel hand prepared to ST2 surface cleanliness. Here we have a photo of Intertherm 2205 applied to ST2 prepared steel at 110 degrees Celsius and then exposed to hot salt spray for 2000 hours. The pull-off adhesion results are excellent, with the failure mechanism being cohesive splitting of the coating. This photo shows Intertherm 2205 applied to ST2 prepared steel at 110 degrees Celsius and then exposed to hot salt spray for 2000 hours, but this time after 3 cycles of the Houston pipe test heating to 205 degrees Celsius. Again, the pull-off adhesion results are excellent, with the failure mechanism being glue failure stroke cohesive splitting of the coating. Another attractive feature of Intertherm 2205 is reduced overconsumption. After application to hot steel at 150 degrees C, the mean DFT was measured and compared to the target DFT, which in all cases was set as 200 microns. You can see that Intertherm 2205 has a mean DFT very close to the target, whereas the mean for the 1-pack IMM coating was way in excess of the target, and equally the epoxy phenolic coatings also had a tendency to be higher than the target DFT. What about increased productivity? Compared to other coating technologies, Intertherm 2205 has a very short overcoating interval and is sufficiently hard to allow re-insulation to occur after 10 minutes when applied above 100 degrees C. This allows insulated piping and equipment to be put back into service up to 50% quicker than traditional coating solutions on the market. So to summarize, traditional solutions are not designed for hot application. And by using traditional systems, both performance and cost issues can be created. Intertherm 2205 was specifically developed to provide ease of application with no special equipment or process changes, and to be applied on prepared hot steel surfaces. Intertherm 2205 reduces the need to take equipment offline. This speeds up application and re-insulation, and so saves time and money. Coming back to AkzoNobel's maintenance offer for CUI and cyclic temperature applications. In the next presentation, we will look at Interbond 2340 UPC and Intertherm 751 CSA that make up AkzoNobel's maintenance offer for CUI and cyclic temperature applications. Thank you for listening to this presentation.